So let's just talk about the B tree. So B tree is basically one MOA tree which is optimized for disk-based data access. Here in B tree, each node can have maximum of m children and m minus 1 keys. Like an example, suppose we have a node. Each node can have maximum of m number of child and m minus 1 number of keys. So that means each node's number of keys will be one less to its number of children. So let's just talk about some of the important features of the B tree. So first of all, B tree stores many keys per node. So because of this, the height of the tree is reduced. Secondly, because it reduces the disk I/O operations or input-output operations. So because of this, it is ideal for large datasets. And thirdly, because it ensures one balanced structure and has the consistent performance. So because of this, it is efficient for search, insertion and the deletion operation. So let's just talk about some of the important properties of the B tree with the order of m. So first of all leaves will be at the same level. That means their depth will be equal. Like an example, suppose we have this tree with multiple nodes. Now all the leaf nodes will be at the same level. So you can see all of these leaf nodes are at the same level or their depth is equal. And secondly, keys in each node are sorted in ascending order. So like an example, suppose we have this node with multiple keys. Now all of these keys will be sorted in ascending order like 1, 2, 3. Now here each node can have maximum of m number of child because the order is m. Each node can have maximum of m minus 1 number of keys because the keys will be one less than its number of children. So this property is applicable for each node except the root node, because in case of the root node can have minimum of 2 children and minimum of 1 key. So that means here this root node can have minimum of 2 children. So here we have 2 children and it can have minimum of 1 key. So here we can have minimum of 1 key. Now in case of these internal nodes, so the internal nodes can have minimum of m by 2, ceiling of this m by 2 number of child, and it can have minimum of m by 2, ceiling of m by 2 minus 1 number of keys. So that means you are talking about these internal nodes except the root node or the leaf nodes. So in case of these internal nodes, so we can have minimum of m by 2 number of child, so ceiling of this m by 2, and it can have minimum of m by 2, ceiling of that minus 1 number of keys. And also in case of this leaf node, the child number will always be 0. So the B tree is always balanced and it has the reducing access time. So it is optimized for large data sets. So that means it can handle millions of records with efficient insertion, deletion and retrieval. So in B tree we can perform the search operation, we can perform the insertion operation, and also we can perform the deletion operation. So all of these operations can be done really efficiently with the complexity of order of log n. And also we can perform the traversal of the B tree with the complexity of order of n. So hope you understand about the properties of this B tree. So in the next video we're gonna see how we can perform all of these different operations. See you in the next one. Take care.